All right, so on 4B.6, we're going to be undoing the transformations and finding pre-images, okay? Basically what we're doing is we're discovering what an inverse is of a square matrix and how it comes by and where does it come from. So we're going to start with part 1 of 4B.6. So for part 1, our goal is to compare two matrix transformation images and summarize any patterns that we see. So these are our two matrices that we're going to compare. For the sake of time, I am going to ask you to use Desmos matrix. So if you have your device out, go ahead and go to Desmos matrix for me. And that's where we're going to be inputting in matrix A and matrix D. And finding their corresponding values. Okay, so up first we have matrix A. Just a recap of how to put it into Desmos in case you forgot. Let me open mine. Can you see nothing? So I'm going to put in a new matrix. It's my matrix A. And what were the values? 3, 4, 2, 7. Yes? Yeah. All right. And then the matrix B is going to be constantly changing, which is okay. I'm going to create my matrix B. It's going to be a 2 by 1. And what's up for my first number? 7. No, for B. Like in 1, 2. 1, 2. I'm going to hit A times B, hit enter. The beauty about Desmos, there's my first output, my first product, 1116. The beauty about Desmos is that if I change this B, it's going to alter what's already been done. So what's our second value we're testing? -3 what? 4. And notice, what does it do? It automatically updates it for me. So we're at 722. What's after -3, 4? 5 what? -2. It updates it, and we have now 7, -4. What's our next one? -1 and 6. And we end up with 21 and 40. Yes, not on your phone. So put the phone away. No, oh, check it. My bad, homie. All right, so what's our next one? 7, 4. And our 3742 is our output. Yeah. That's what we're going to talk about next. Okay. All right, so are we comfortable with that? Next is going to be matrix D. So I'm going to create a new matrix. You can always just change the name of a matrix. It's weird. Just hit enter. It's like a, and then if you want D, the next time it makes a new one, it'll be D. If it really bothers you that much. Otherwise, just keep it pushing. All right. On D, to make the fractions, you see the / button down by your shift, or that's how you're going to make your fraction. So our first fraction is what? So I'm going to press 7 / 13. You can. I didn't want to take my hands off the key. 7 over 13. And then we have -4 over 13, right? And then we have -2 over 13. And we have 3 over 13. And that's my D. Yes? I'm going to go up and just manipulate C. Well, I'm going to delete C because it's bothering me to see a naked thing in there. So we'll create a new matrix. No, not you. I want C. Beautiful. D is done. Any questions about D? Now, I'm going to be doing the C. C is going to be my 2x1, and I'm going to test out the points for the 2x1. All right. You keep going, and then I will be walking around. So we're filling in table D. Leave them blank. We're going to talk about them. You have to multiply DC. You did? You sure?
You good?
Wait, I'm at
Or we just learned that in 5 that order matters.
Oh.
Wait, no, never mind.
Oh, they put you on scale. Just don't use out there. Just don't on scale. Never once was on scale. Just bro, that never once was on scale. Like that was going past you and she was. No, they got that from once. That's when I started grabbing them. That's when I got mad. Things like 8 marks something. Oh, you did a ref game for there. Is it that hand? It's nothing to do with it. Some beautiful football. I'll watch soccer. Call that.
Like, how is this possible?
You go see, do you hear? Oh.
Like, what do you mean?
That's a review of like solving for.
Honestly, I say that. You don't want to.
That's the beginning.
You told me about it.
See that. Just as Vincenzo.
You didn't refresh. I opened it yesterday. I opened it yesterday, ma'am.
There's that same HOT then.
Wait,
Um,
don't count off, don't count
Yeah,
Yeah.
yeah, so it's solved basically.
I didn't know you were
Like,
there.
We did. Who's it?
Yeah, that was-
This is where these.
Like a thousand? Yeah. I'm not doing this myself, I'm guessing.
I didn't recognize.
Oh, yeah.
Oh, yeah, this is the last page. Well, this is.
I guess.
What's up?
Definitely, oh, no, that was, because I don't know how to do this. Took my notes out, I'm gonna take them back.
At least I'll put it in someone's.
All right, are we ready to check? Philip? Make it two good.
You did, what's the water break?
We're gonna do those together.
All right. I know how to do it, but I don't.
Okay, let's talk about what you should have ended up with. All right, so when you came to the conclusion, this is what your A and your D should have looked like.
Yeah.
Did anyone make an observation?
Yes, I stopped using decimal stuff.
Yeah. And what was that observation?
It's like, the observation is, the solution of that is like the. The solution of A, is what we use to
There we
put in for the, for.
Exactly. I think we're all saying the same thing, just not completing the sentences. But the pre-image of one actually ended up being the image of the other, right?
Yeah.
The input was the output on the other end, correct? Is that what we concluded? We see that pattern? Okay, that's because these are called inverse inverse matrices. Okay, these are inverse matrices of each other, meaning that as a class, let's say we did 1, 0. So we're gonna do 1, 0 on A. I'm gonna just write it next to it so you can see me doing it. So I'm gonna let X and Y be 1 and 0. Well, 3 times 1 is 3. 2 times 1 is 2. So the output's going to be 3, 2, right? So therefore, based on our conclusion that these are inverses, what would be the reciprocating side, the opposite over here? It would be 3, 2, and 1, 0. That's because they are inverses. When you learn about inverses in Algebra 1, your X and your Y switch places, right? Well, because X and Y are connected, they're tied together, your whole coordinate is switching places. So your pre-image and your image are flipping places with the inverse, okay? Does that make sense? All right, so let's talk about part 2, determining the inverse of a transformation. Without having to make a whole table to see that pattern, how else could I tell, right? That's what we're gonna focus on. How can we tell, and is there a formula that can come from this? All right, on your part 2, you're going to only write down the matrices. So only write what I'm boxing. And we're gonna come up with some observations. So part 2, step 2 is saying, looking at our entries, what are some conclusions or observations can be made about them? So someone give me a conclusion. Like looking at the numbers, what do you notice happened from transformation A to transformation D? Okay, everything is divided by this magical number 13, right? So we divided by 13. Where did that come from? What else happened? Okay, so we noticed that 4 and 2 change signs.
Wait, what side are we doing?
We're on part 2.
This? Or the-
Inside part 2. So, you don't see the boxes?
That's what we're putting. Oh.
The numerators like
I
are
can
the
do it.
same.
Okay, the numerators are the same, but not exact same, are they? Okay. Any other observations? What moved around?
Yeah.
They're just a little change, right? So like our 7 and 3, they did what? Flipped, right? They switched places. So 7 and 3 switched.
Yeah.
So those are the conclusions that we can make. Now we're going to apply. See, these conclusions that we make go to everything. Hello? Oh, it's okay. Oh, just put the calendar, I'm guessing. Yep.
Good.
Yes, ma'am, and then there were. You came to the minute with the project.
What?
All right. No problem.
So like, it's not noticeable. It just looks like the red print.
All right,
What's the test for? What's tomorrow?
everything, all things, Unit 4. All things Unit 4.
Oh, come on.
All right, here we go.
Wait, no, go back. We got two back.
We got 2 and 1. All right, so with what we have, it says, what is the value of the determinant of A? So we're gonna see what else can we notice? So what happens when I find the determinant of A? How do I find the determinant? We cross multiply. So when we look for the determinant of A, we cross multiply. 3 times 7 is 21. And 2 times 4 is 8. And what do we get? 13. Oh my gosh. What? You don't say. What is significant about 13? Oh my gosh. In D of X, everything is divided by 13. Oh, so another connection. We noticed that everything was divided by 13, but now we know where the 13 comes from. And that 13 comes from the determinant of A. Okay. So it says, which of your observations from problems 2 and 3 are hold for other pair of matrices, okay? So if we were to, we didn't do this part. We're just gonna cross that out. I shortened our notes. Nope, I shortened our notes. All right, so in conclusion, we should have created a formula, and here's the formula that we create to find the inverse of a matrix. We stated that you are switching our 3 and 7, right? So we switched the places of those. Then we stated that our signs changed, right? On the other diagonal, our signs changed. Is that correct? Is that what happened? Okay, and then the third, yes,
Does it matter which like set of numbers?
it does. Order matters.
So we have to switch these two.
Yep.
Okay.
The diagonal matters. And then we said that we discovered that lo and behold, everything was divided by the determinant. When we did operations for matrices, we talked about we don't divide, but we multiply by that reciprocal, right?
Yeah.
So instead of dividing by 13, we're multiplying by 1/13 or whatever. Okay, so knowing this, can we now find the inverse of this function, of this transformation? All right, let's try it. So we're gonna find the inverse of t. So we're gonna make it as t, and we're gonna put a -1 to let us know that this is gonna be its inverse. So the first thing I'm gonna do is figure out what is our determinant. How do I find the determinant? -2 times -4 is? Which is 5. So we found our determinant. Then we said we're switching from top right, top left to bottom right. So -2 and -4 are going to switch. And then we noted that the signs on the other diagonal changed. So instead of a +5 became a -5, and instead of a +1, it became a -1.
The whole thing.
So in conclusion, what's 8 minus 4? 8 minus 5? 3. So our final matrix is -4/3, -1/3, -5/3, -2/3, and that would be our inverse. How do you feel about being able to find the inverse of a 2x2 matrix? Doable? We got it? Doable? All right, note here, if your determinant is 0, what does it say? There's no inverse. So if my determinant is 0, then there is no inverse, which makes sense because can 0 go in the denominator? No. All right, are we good there? All right, on to part 3, which is the other half sheet. I know y'all doubted that we may not be able to get there. We can't. We're gonna just keep hope alive and pretend that we are.
Well, are we really